Hi! In this video, we introduce you to Justine, our demo for self-organizing data schemas. Storing data in a structured format is often crucial for later analysis. Unfortunately, developing a useful schema can be challenging and may result in high overheads. Imagine the government of a city wants to improve cleaning and fixing their infrastructure. They ask their citizens to report any issues they encounter, such as broken streetlights or overflowing trash cans. Now, these reports need to be stored in a manner that allows for efficient processing. For different kinds of issues, different types of information are needed. For example, to identify full bottle banks, the street or square they are located on will be sufficient, while a more detailed address is required for a broken streetlight. After some time, there might be reports about new topics not considered when setting up the system, for example about electric scooters blocking the sidewalk. Employees might also decide it would make sense to add further structured information, such as the garbage disposal tours, to the system. A good storage system for this use case should, therefore, store each entity in a semantically meaningful way and be able to accommodate storing new types of information that were not considered during the initial setup. Currently, there are two general options for that. Relational databases can be carefully adjusted to store all relevant information and provide a good overview. Unfortunately, this requires a significant manual overhead for designing that schema. Moreover, the system can only store entity types anticipated during schema design and requires manual adjustment for new ones. On the other hand, key value stores can store all kinds of data, but require schema checking on read to guarantee that relevant attributes for automated processing are available. Due to the lack of a strict schema, manual exploration is more challenging. Therefore, we propose database systems that can adjust the schema autonomously based on the incoming data. This offers the advantage of a flexible storage, similar to key value stores, combined with the advantages for data exploration found in relational databases. Our system, Justine, is a first step towards that vision. It works on top of a relational database and can execute vague inserts without the need for schema specification. It will automatically adjust the schema for new information and entities that are not yet supported. Insert queries typically contain a substantial amount of schema information. Relying on this information would just shift the schema design from setup to query time. To truly build a database with self-organizing data schema, the database must be able to operate without this information. Therefore, Justine supports vague queries that might lack the table name, column names, or both. It can also handle synonyms and alternative terms. Justine finds mapping between the insert and the existing schema, creates new columns and tables if needed, and then executes the adapted query. The semantic mapping is achieved via two fine-tuned Llama 3 models for table and column prediction. To demonstrate our approach, we integrate it into a web application. A user can start with an empty database or select an existing scenario to interactively query our system. They can now enter SQL-like queries and ask the system to insert them into the database. For simple queries, for example an insert in the empty database, Justine will directly perform that input. In other cases, it will show how it would handle the insert but allow the user to select another target table or change the mapping to the columns. After each insert, Justine will visualize the current state of the database. As a second functionality, users can test how well Justine works without human interaction and watch the schema evolve automatically. To do so, they select a given workload and modify its properties, for example the ratio of queries, without table or column names. By default, Justine will start with an empty and schemaless database, but users can also decide to start with a database that already contains a suitable schema to evaluate just the mapping functionality of the system. Justine will then execute the adjusted workload one by one, visualizing the state of the resulting database after each step. Once the complete workload is inserted, a user can replay the insertions or jump to a specific query to inspect the effects in more detail. If you're interested in further details, please refer to our demo paper. Thanks for watching.